Today we're covering graphing absolute value notes. Think back to 2 units ago when we were graphing parabolas. And they had equations that would look like this. Y equals a, x minus h in the middle, in parentheses, squared, plus k. Now, remember, a controlled whether or not the parabola opened up or down. Okay? If a was positive, the parabola opened up. If a was negative, the parabola opened down. Remember, the letter k, the number on the very end, that moved the parabola up or down. So if the k was like a +2, the whole parabola moved up 2. And if k was a -2, the whole parabola moved down 2. Remember, h, inside the parentheses, that moved the parabola left and right, but always moved it in the opposite direction. So if it was x minus 3 squared, that moved it 3 to the right. And if it was x plus 4 squared, that was 4 to the left. It was always opposite. Okay? Well, absolute value graphs behave exactly the same way. In fact, they kind of look like parabolas, except parabolas look like that, like a U, and absolute value graphs look like a V. Okay? But they're very, very similar. So let's graph this first example here together. So I'm going to make a t-table, and I'm going to put x into this equation, y equals the absolute value of x. That's what we're trying to graph. So if I plug in a -3, of course, the absolute value makes it +3. If I plug in -2, the absolute value makes it 2. Plug in -1, the absolute value makes it 1. And then, of course, 0 would stay 0, 1 would stay 1, 2 would stay 2. So if I graph this, I'd go to first point, -3, 3, -3, 3. Second point, -2, 2. Third point, -1, 1. Fourth point, 0, 0. Fifth point, 1, 1. Sixth point, 2, 2. So it actually is a V. Okay? It's not a U like a parabola. It's a straight V. Okay? Now, we can write the equation of an absolute value graph the same way we wrote parabola equations. It has exactly the same rules. Okay? So our parabola equation, remember, looked like this. X minus h squared plus k. This equation just has the absolute value instead of the squared. And the absolute value is what's going to make it turn into a V. So here's some graphing examples just to show you. X plus 3, remember whatever's inside the parentheses or the absolute value moves it left or right, and it's always opposite. So since it's x plus 3, instead of the V starting in the middle, the V starts here at -3, and then it's just a V. For this one, you'll notice we have x minus 2 in parentheses, or inside the absolute value. That moves it 2 to the right. So instead of starting here, it starts 2 over, and then it's just a V. Our third example, when we're adding a number outside of the absolute value, that moves the whole V up 2 units. 1, 2. So there's the V. Okay? And it's not in the absolute value symbol. So it's the number outside the absolute value that moves it up or down. So you'll see in this example, since it's the absolute value of x minus 3, it moves the whole absolute value graph, the V, down 3 units. So the number on the outside moves it up or down, and it moves it whatever it says. So if it's negative, it moves it down. If it's positive, it moves it up. For numbers inside the absolute value signs, it moves it left or right, and remember, it has the opposite effect. So a +3 actually moves the V left 3, and a -2 actually moves it 2 to the right. And then, of course, we can combine multiple moves. So the +2 inside the absolute value moves it 2 left, and the +1 on the outside moves it 1 up. This one, the x minus 3 moves it to the right 3, and the -2 moves it down 2. So right 3, down 2. And then it's just a V. Be careful when you're drawing these. Don't make it curved, okay? You need to make these perfectly straight like a V. Now, if I put a negative sign outside the absolute value, that just flips it over. So instead of opening up, it opens down. And like parabolas, if I put like a 3 out front, that's like the slope. So instead of just going over 1, up 1, I'm going to go over 1, up 3. So it makes it really skinny. Okay. So now you should go to Moodle and try to match some equations to their absolute value graphs.